please send some important recorded session links like
Yes,
STAT and
so
the last term for end.
yes, it has not been uploaded. I will just inform to upload it. Okay, for week 11 and 12, it should get uploaded by tomorrow morning.
Although I understood till lecture 5, but I could not solve the activity question, the first activity questions. How do I decide whether H naught is this and uh, HA is
Oh,
this?
you have watched till what lecture?
Fifth lecture.
Fifth lecture you have watched.
Till fifth, I am clear, but I could
Yes,
not solve the
yes.
activity question 1. Second, I was able to solve.
Oh, okay. Let me go through each of the sections and we can see few problems also.
Ma'am, your that mock session really helped me in the exam.
It helped. Oh,
Yeah,
that was good.
it helped me till 90%.
Okay.
It was
Good to
really,
hear that.
really helpful. Really helpful.
The concept, because the
That was a
concept will
great
be
session.
same. The concept will be same because there is no difference in what you get in the exam. There is no new
I got
concept,
stuck in
right?
4 of the questions. The rest of the questions I sailed through easily.
Okay. All right. So let's start now. I'll just give the brief idea of what is hypothesis testing and what are we doing there. So in hypothesis testing, like as you have seen in estimation problem, like you have some unknown parameter and you want to estimate uh, the value of the parameter using some samples and you want to just get the like what the value of estimator is or when it was Bayesian estimation it was more like you had seen that parameter is a random variable and we are trying to estimate that. Similarly, in hypothesis testing, what we do is we check the hypothesis. Like we have some belief about a situation or something, and we want to check whether this is true or not. Like for example, here you have to check is a coin authentic or counterfeit. So you have a coin and you want to know like you want to check like whether this coin is authentic or counterfeit, whether the probability of getting a head or a tail is zero point 0.5 or it is something else. So in this case we are saying, let's say if the if as we all know, if the coin is authentic, probability should be zero point 0.5. So probability is zero point 0.5, probability of it is zero point 0.5 when tossed, and probability of head if it is counterfeit, let's take it as zero point 0.6. So basically, probability of head not equal to zero point 0.5. So what you can do here, so you can toss your coin so many times and you can get the results, and on the basis of that you can check whether the coin is authentic or counterfeit. So using hypothesis testing, how do we do it is like we decide we take two hypotheses. So one we say it is null hypothesis and the other we say is alternative hypothesis. So whatever we want to test, okay, whatever we want to test, we say that is a null hypothesis. So like in this example we want to test whether probability of head is zero point 0.5, so we'll put into the null hypothesis. So null hypothesis we denote it by h naught, and there
You
is
mean we can say that null hypothesis is the hypothesis which goes along with the belief, right?
yes, whatever you want to check, okay, you just put it
It
there,
goes
it
in
goes
line with
along with
that.
it. Yes, yes. So or and also basically I am not sure how many of you have watched the complete lecture. So there is something called simple hypothesis and composite hypothesis. So you always take the simple hypothesis in your null hypothesis. So what is mean by simple hypothesis? Simple hypothesis is in, like for example here its probability of head is zero point 0.5. So that whatever is equal to, right, that we say it is simple hypothesis. Let's say we are testing the mean, okay, and we are saying mu is equal to mu naught. Mu naught is some particular value that your mu takes. So we are saying, let's say h naught is mu equal mu naught. So this is a simple hypothesis. And what will the composite hypothesis be? Composite hypothesis be, if you are taking the null to be mu equal mu naught, in alternative you have three possibilities. Either mu is not equal to mu naught, or mu is greater than mu naught, or mu is less than mu naught. Okay. So all these hypotheses, you see, there is no these are inequalities here basically. So one is not equal, one is greater than, one is less than. So such kind of hypothesis, we call it as composite hypothesis. So we always try, at least in throughout this course that you are going to see for week 11 and 12, you are going to take the null hypothesis to be simple hypothesis. Okay, always
Yes,
take
ma'am. Could you pause for a moment here?
Yeah, yeah.
Suppose, let us take a small example. Suppose we are tossing a coin. We are getting head and tail, right? So what is mu here? What is mu equal to mu naught here? Suppose
So
we say that
what is the mean here? If you are taking the coin example, the mean will be what?
suppose we are tossing it 10 times.
Okay, so if you are, okay, 10 times, if let's sum it over, then what will be the mean? Like
The
if
number
you
of
are
heads, because
The success.
let's say you are tossing a coin 10 times, okay?
Yes,
So mu will be like, let's say the success is getting ahead, and you are interested in how many times head has occurred. So your mu will be just NP, right?
Yes,
I mean 10 times 1 by 2, so 5.
Yes, ma'am. Taking it as a Bernoulli.
Okay, then probability of mu equal 0.5 basically.
Ma'am, regarding this, can you take the practice assignment?
Yes, ma'am. Just please explain it with this example only, just
question one.
in written.
Activity one, question one.
Oh, okay. Let me go to the activity.
I am basically, my confusion is between mu equal to mu naught and what is that C here?
Critical value. Yes, I will tell you.
Could you explain? I am not clear about it. What is mu naught? What is mu not equal to mu
so-
naught, and what is C?
Okay. So mu naught we'll see later. But first, what is critical value is, like, critical value is up to that value. You are, I mean, that is your either you accept at that point or you reject at that point. Like if we say, let's say for example, my test says I am going to reject the null hypothesis if I get 5 out of 10 heads. Okay, then
Okay.
this 5 number, right, this number 5 is going to be critical value.
Okay.
So anything that decides whether you are going to reject or accept the null. So throughout this, we are just going to deal with whether we are going to accept the null or we are going to reject the null. Okay. So whatever is the criteria, that deciding factor, basically, that boundary which distinguishes where you are going to accept and where you are going to reject, that is called the critical value. I will just go to one example here.
Yes,
The
ma'am.
first question of activity.
Okay. Just give me a minute. Yeah, can you see it?
Yes, ma'am.
Okay, so what does the first question says here? It says a manufacturer of a certain brand of rice cereal claims that a manufacturer of a certain brand of rice cereal claims that the average saturated fat does not exceed 2.4 grams per serving. Okay. State the null and alternative hypothesis to be used in testing this claim. So null, what we said, we always going to put the simple hypothesis. Okay. So our fourth option is already discarded. Now we have three options. So null, you are saying you have mu equal 2.4.
Should it not be less than or equal to 2.4, ma'am? Null.
Yes, ma'am.
Should it not be
Basic
less
confusion
No.
is this only in this question.
Should it not be less than or equal
Because
to
it is
2.4?
The
it is
null,
saying fat content does
Yes,
not
yes.
exceed. That means it is less than or equal to 2.4. Why equal to 2.4?
because we want to check for 2.4. That's what I said. Like whatever, like we always keep in the null the simple hypothesis. So let's say I am saying it is 2.4, okay, and I want to check that this is less than, does not exceed 2.4, right? So does not exceed 2.4, it means I want to check that this is less than 2.4.
Okay, you have taken critical value as 2.4. Okay.
No, not critical value. This is not critical
But the
value.
alternate will be if it is greater than 2.4. Now, so second option should be
Why?
correct.
Okay,
Whereas
why do you think it should be greater than 2.4?
the alternative should be that it is greater than 2.4.
No,
Alternative
like
Ma'am, does not exceed. No, ma'am. That means
Does
then the
not-
alternative should be clear to
Yeah,
exceed.
ma'am.
Then only it is
Suppose
exceed.
then acceptance set for this question would be that fat is 1 gram, then in another sample fat is 2 grams, in another it is 1.5 grams. This is the acceptance set of this, na?
yes.
So I think the second option should be correct, whereas I think there they have given the third option to be correct.
Ma'am, is it the
Wait,
mu?
let me check. Wait.
Is it the average value that is 2.4 is the mu?
Average, yeah, mu is the average value. Like you were asking about what is mu naught. So here you see that it says the average saturated fat content.
Mhm.
The average
Okay,
saturated
that
fat
is why
content.
this is
So that
equal
is
to.
mu, and you can say this mu naught is 2.4.
Yeah, okay.
Okay, mu naught is 2.4, and you want to check that your average saturated fat content does not exceed 2.4 grams. So this is what you want to, like, this is your claim. So whatever is your claim, you just put it in the alternative hypothesis.
Not getting it, ma'am.
But he is already
Okay,
claiming that.
let's look at different example. Okay. Let's look at this example. So it says a real estate agent claims that 55% of all private residents built today are 3-bedroom homes. Okay. To test this claim, a large sample of new residents is inspected. The proportion of these homes with 3 bedrooms is recorded and used as the test statistic. State the null and the alternative hypothesis to be used in this test. So, this is clear?
Yes, because he is claiming that it is 55. So H naught is P equal to 55 and alternative is P not equal to 55. So here I think there is no confusion regarding the answer.
Okay, here there is no confusion because we just want to check if it is 55% are 3-bedroom homes.
Mhm.
So this is clear. Okay. Is there any other example
Ma'am, can I ask something in the same question?
Yeah.
Ma'am, if the question would have been the real estate agents claims that 55% of all residents being built are not 3-bedroom homes, even
Okay.
then the null would have been P is equal to 0.55.
P equals 0.55.
Even then,
Yeah, even then.
if he says, all right, so we will always put the is equal to part in null.
You always put simple hypothesis in the null hypothesis.
Null.
And whatever
No matter
you
what the
want
question is, okay. No matter
and
what the question
whatever you
statement
want
says.
to,
Means whatever does not fits in our belief, right? In this hypothesis, that is added
whatever you want to check, right? Just put it in the alternative.
Okay, whatever we want to check, we will put in alternative, and rest we will put in null.
Yeah, not rest.
Okay,
you just in the null you put simple hypothesis.
Okay, that is.
Okay, ma'am. We can we can say that what goes in our belief, we put it in the null hypothesis, and whatever does not fits the criteria, we put it in alternative hypothesis?
No, okay. How you can decide is like whatever you want to claim or you want to check, put it in the alternative,
Okay.
and whatever is your simple and just put the simple hypothesis in the null.
Well, then the simple hypothesis is just a fact which is given in the question.
Simple hypothesis is a fact. Yeah, yes.
Simple hypothesis.
It will be given in the question.
In other words, my question is, how do we identify that this is the simple hypothesis? This is the fact which is given in the question.
Yes.
Question 1
So
is not still clear, man.
Question 1 is still not clear. So in this one, like first problem, what is it that you want to check?
We want to check whether it exceeds 2.4 or not. The manufacturer
Does not exceed.
We need to check it does not exceed.
Does not exceed. Yes, that we will put in alternate.
That we put in alternative. So that is your average
3.
should be less than 2.4.
That is what the manufacturer is claiming, right?
Yes, and that is what we have to check.
Yeah, so that you have to put in alternative.
So what if it exceeds then?
And in simple, the fact is given that we are checking
What
for
if it exceeds,
fat
then
content to be 2.4. Average
See,
fat.
for now you're saying your claim is like what your belief is that mu is 2.4, and the manufacturer is claiming that this mu is 2.4. So if you get mu to be greater than 2.4, like you have designed a test, and on that basis you are coming to the conclusion that I'm not going to accept, I'm not going to reject the alternative. It means in that case you're going to accept the null. You're going to go with your belief.
Ma'am, not
Let
clear,
me
ma'am.
see if
Ma'am,
there is
actually,
another question. Wait. Okay, these are. Test is already given. Can you tell me if there is any question?
what is power and size test, ma'am?
I will come to that. I'll come to that.
Ma'am, even in activity 1.1, we have how to find alpha and beta. That questions are there. I think if you.
Okay, I will just give it the definition, but I just wanted to check once some example.
In most of the questions, ma'am, it's already given what is HO and what is HA.
Okay, what about practice assignment?
We don't have to think about that. But in that particular question, it is not given. We have to find what is HO and what is HA.
Okay, look at this question here. This air crew escape system. So it says air crew escape systems are powered by a solid propellant. The mean burning rate of this propellant must be 50 centimeters per second. Okay, we know that the standard deviation of burning rate is 2 centimeters per second, and engineer suspects that the mean burning rate is greater than 50. The engineer decides to test at a significance level of 0.05 and selects all that is later. So just look till the second line.
So here alternate is that it is greater than 50, ma'am.
Greater than 50, right?
Alternate is that it is greater than 50.
Yeah.
And HO is that it is 50.
H naught is that it is 50. So here, even here again, like you wanted to check, the engineer wanted to check that the mean burning rate is greater than 50. So that's why we have put that into alternative.
Okay.
Mu greater than 50.
Okay.
So H naught is mu is equal to 50 and H alternative is mu is greater than 50.
Greater than 50. Yes. Again, you look at this question number 6. Question number 6 says, suppose a manufacturer of memory chips observes that the probability of chip failure is P equals 0.05. A new procedure is introduced to improve the design of chips and lower the probability of chip failure. To test this new procedure, 200 chips are produced and tested. So again here, what is going to be your null hypothesis, alternative hypothesis and null hypothesis?
Less
Ma'am,
than
null is chip
0.05
if failure is equal to the failure of
Yes.
the probability of chip
probability of
failure is
failure.
0.05. This is null hypothesis.
Yes. So null will be P 0.05. And
05
since
and
you have
alternate will
introduced
be
the new design and you want to improve the design and
So less
lower
than
this probability,
0.05.
so P will be less than 0.05.
less
This is
than
what you wanted
0.05.
to
This
check.
is the alternative,
Again.
na?
Yeah, alternative.
Yes.
So
Okay.
again, this is
Okay.
what we wanted to check. So we have put into the alternative.
Alternative.
Okay, ma'am.
Okay.
Now I got it whether this is null and this is alternative. But why this null hypothesis is like this only? It does not goes along with our belief.
And before that, I just want to check on this question. For this question, the alternate hypothesis is uh, P is less
Question number
than,
6. Okay.
yeah, it is less than 5 out of 200, and the null hypothesis is equal to 5, right, ma'am?
Null
5 or 5%.
0.05.
Yeah, yeah,
Yeah.
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 Okay, ma'am. Okay. Thank you.
Ma'am, what is the logic of putting what we want to check in alternate hypothesis?
Let me see what sir has given as a definition.
There is no specific definition given for null hypothesis or alternate hypothesis.
It should be there. It's not there. Okay.
In lecture, ma'am, it only says that it is a subset of all the samples. That is all it is written about null hypothesis.
Oh no, that was about the test rate. In how many tests are possible?
Hypothesis.
You have to. Okay. Okay, so like it just take care of this, that whatever claim you want to check, or you just put that into alternative hypothesis, and in the null you just put as a simple hypothesis. Then okay, after the null and the alternative hypothesis, like you have some factors, like you take some test, but how do you check whether the test is good? I mean, what all the matrix are there to check for the whether your test is good or not? So you have two matrix defined for hypothesis testing. One is your significance level and other is your power of the test. So significance level of the test. Okay, so significance level of the test, which we also call as the probability of making the type 1 error, or the size of the test. So it is defined as like when you reach to a conclusion. Okay, and like even though in real your null was true, but you reached to a conclusion and rejected H naught. Okay, so that is called the significance level of the test. So I mean, when you start, you actually don't know. Okay, but it is possible that whatever your H naught was, okay, that was true, but still you went and you rejected this H naught. So by doing this, you are making an error, right? Like even though
Rejecting H naught means accepting HA.
yes,
Yes.
rejecting H
Rejecting
naught
H
means you
naught
are
is the
accepting
same as
HA.
accepting HA.
Yes,
H naught and HA are complementary with each other.
H naught and HA are complementary with each other.
Okay.
Yeah. So like what we're saying here is like you knew, like you don't know that, but let's say your H naught was true, okay, but still you had the test and you came up with the conclusion and you rejected your H naught. So what is the probability of making that error? Because by doing so you are making an error, right? Like H naught was true, but still you are rejecting it. Okay, you are making an error, that you understand.
So that is alpha.
Yes, so you want to bring this alpha to as low as possible. Okay,
Okay.
so
Ma'am, I
that
think it's better if you have an example and
I
if
will
you
come to
explain this.
I'll come to an example. So you want to make this error, you want to make this probability of making this error to be as low as possible. So this probability of making this type 1 error, so at till what level of significance we can go to, okay, that is called the alpha or size of the test or significance level of the test. Now the other case can be when your alternative was true. Other thing can be when your alternative was true and still you are going and accepting your null hypothesis. Again, by doing so, you're making an error because your alternative was true, but still you are accepting H naught, right?
It could be say that when HA is true, we are rejecting HA.
When HA is true, we are rejecting HA. Why?
Instead of accept H naught,
Okay. Oh, okay, like that. Yeah.
is it true? Is it equally valid?
HA is true, you are rejecting H naught. That is called the power of the test. Yeah, that was just 1 minus beta.
No, ma'am, he's saying if HA is true, you reject HA.
Like when
okay,
H naught is
okay,
true,
okay.
when H naught is true, we reject H naught, we make an error. I got it. Right. When HA is true, we are rejecting HA. That is also an error. This
That
means
is also an error, yes.
instead of rejecting
Yes.
HA,
So
we have
rejecting HA means
accepting
you are
HO.
accepting H naught. Yeah.
So if accepting HO means rejecting HA and accepting HA means rejecting HO. Can we say that like that?
Yes, you can say that.
Okay.
Yeah. So that is called your type 2 error, and again you want to make this error to be as low as possible. So that is type 2 error, and there is something called power of a test. So power of the test is just 1 minus beta. Okay, so your beta is what? Your beta is accept H naught when HA is true. So what will be 1 minus beta?
Reject HO when HA is true.
Reject H naught when HA is true.
Sorry, ma'am, could you repeat this?
Ma'am, but 1 minus beta is accept HO when HA is true, ma'am.
No. That is beta. Your beta is beta, that is called probability of making type 2 error. Okay. So that beta is when HA is true, you are accepting H naught.
Only beta.
Only beta. Yeah.
Okay.
Then, ma'am, what is 1 minus beta?
1 minus beta is called the power of the test.
No, you were just explaining that something before that.
Something before
But
that.
in the slide, it is
Like,
written that
okay,
1
I got
minus
it.
beta is
What is
accept.
beta?
Okay.
No, okay, see here. Power of a test is 1 minus beta. Okay.
Yes, ma'am.
Type 2 error is except H0 when HA is true. Okay. And beta is probability of making this type 2 error.
Yeah, that's what, ma'am.
Okay.
Then
Type
1
2
minus
is when
beta
accept
is
H1, then when it is true only, no? We are not rejecting it. That is 1 minus beta, no?
1 minus beta is when HA is true, you are rejecting H0.
Okay.
But ma'am, this is not an error. 1 minus beta is not
1
an
minus
error
beta
then.
is not an error. 1 minus beta is
Only
not an
beta
error.
is an error.
Beta is an error.
Okay,
Beta
okay,
is
madam.
probability of making type 2 error. Alpha is probability of making type 1 error, and that is when H0 is true, you reject H0. Okay.
Yes.
And
Okay.
beta is probability of making type 2 error, which is when HA is true,
Is
you
true.
accept
Except
H0. And power of a test is 1 minus beta. So that is when HA is true, you reject H0.
Reject. This is a good
And can
thing.
you please write these 3 points, ma'am, on the slide? We will note it down.
Slides. Okay.
Just write, ma'am.
Just
1 minus beta.
small
1 minus
notes,
beta.
ma'am. I
Okay,
will
wait,
just
wait.
make it now.
Okay.
Ma'am, can I say something?
Yes.
Ma'am, I have checked my portal in the live session section. There is no slides
Yes,
recorded.
I checked that. I have noted it down, and it will get uploaded by tomorrow morning.
Yes, ma'am, please.
By tomorrow morning, it will get uploaded. Even for week 12, it will get uploaded.
Okay.
Ma'am, excuse me.
Yes.
Yes, so ma'am, will we get this the live recording of this session on YouTube?
You will get the recording. That
Okay,
also will get updated tomorrow.
okay.
Okay, so alpha is, you can see this, right? You can see the screen.
Yes, ma'am.
Alpha is probability of making type 1 error. Okay. And this is probability that given H0 is true, you reject H0. Okay. Then you have beta, that is called probability of making type 2 error. And this is probability that given HA is true, you accept H0. Then you have 1 minus beta, that is called power, and this is probability that given HA is true, you reject H0. Okay.
This is a good thing.
H0 is nothing but.
Okay, ma'am. Thank you, ma'am.
Okay.
Excuse me. Hello, ma'am.
Yes.
So rejecting H0 is nothing but accept HA for given HA is true. Isn't it?
Except HA. Yeah, you can say that.
This is a good thing, no, ma'am.
Yeah, this is, you want this power to be strong. So you want the power to be very close to probability 1. And you want this alpha and beta to be close to 0. Okay.
Alpha is to be reduced.
Alpha and beta
Always.
both has
Both
to
are
be reduced.
reduced.
Only if you reduce beta, your power will increase. Right?
Yes, ma'am. 1 minus beta. Okay.
Ma'am, in 1 minus beta, why don't we write when HA is true, accepting HA? Rejecting H0 means accepting HA.
Just way of saying things. I mean, it's it's like that only. Like even all the definitions when you see, like there can be different way to say it. Like you can say I'm rejecting my accepting HA, but instead of saying I'm accepting HA, will say I'm rejecting my H0. It's, you will see everywhere like that only in hypothesis testing.
For
It's the
example,
same thing. Yeah.
in that saturated fat example,
Okay.
2.4 less than, we said that the HO is it is equal to 2.4 and HA is it is less than 2.4.
Yes.
Suppose we are rejecting HO, means that it is equal to 2.4. So it can also mean that it is greater than 2.4. Can it not? Rejecting H
Wait. You
naught
wait.
means
Can you repeat? You are saying?
rejecting H naught,
Hmm.
which is it is equal to 2.4. It can also mean that the saturated fat is greater than 2.4.
Saturated fat is greater than 2.4, but we are checking for less than 2.4, right?
Yes, we are checking for that, but rejecting
When
H
we are
naught means
rejecting H naught, it means we are accepting HA.
okay. So it's always like that.
Yes, it's always like that.
Okay, okay,
You say we are accepting our alternative hypothesis there. We are
okay,
rejecting H naught. It implies that you are going with the alternative hypothesis.
okay, okay.
So there are various examples. Wait. Okay, just see this question. It says consider 100 tosses of a coin, which could be either authentic with probability of heads equal to 0.5 or counterfeit with probability of heads 0.6. Okay. Suppose T is the number of heads seen. Now consider a test that rejects H naught if T is greater than C. So here the test is already defined to you. So first of all, we will write down what all information is given to us. Okay. So from this question, first you will have to decide what is your null hypothesis and what is your alternative hypothesis. So what is your null hypothesis here?
Equal to 0.5, ma'am. Probability of it is equal
Probability
to
of head
0.5.
equal to 0.5.
Probability of it equals 0.5. And what is your alternative hypothesis?
0.6.
0, you are saying? Yeah, 0.6. So I can also say this, that probability of head is greater than 0.5.
Yes, ma'am. Yeah, we can say.
Okay.
That will be composite.
Yes. Now T, you have a test defined already here. So you are saying the T, what you are looking here, right? This capital T. So we call that capital T to be test statistic.
Ma'am, could you pause for a moment?
Yes.
These three things, the null hypothesis, alternate hypothesis, and the test, these three are the different things, right?
These three are the different things, yes. And you decide the test from your hypothesis. So there is one more thing that is called test statistic. So that will come to it later. So for now, and there is critical value, right? So see here, it says consider a test that rejects H naught if T is greater than C. So what is T? T is this test statistic basically. T is a test statistic. And how is it defined? It is defined as number of heads seen. Okay. T is what? Number of heads seen.
Okay.
And number of heads seen as in like what will be the distribution in that case? So basically we are saying it should be x1 plus x2 plus up to x100. And how did we define this xi's? So xi's are defined as xi equal 1 if you have head. Otherwise, if it is state, we are putting xi to be 0. So if you sum all this x1 plus x2 up to x100, you are going to get number of heads seen, right?
Yeah.
And that we are calling it as our test statistic.
That means statistics, particular statistics which we want to extract from a test sample.
But from the test sample, yes. Now after this test statistic, we have the test. So what is the test? Here the test is given to you. Consider a test that rejects H naught if T is greater than C. Okay. So if this C is what? This C is a critical value, because this is the deciding factor. Okay. Now you have to find what is the significance level of the test. So what is the significance level? Significance level is probability of making type 1 error. That we also called as alpha. And what is alpha? Alpha is probability of
rejecting H naught
H naught when H naught is true.
H naught
Okay.
is true.
So this H naught, what was this H naught? H naught was that mu is probability of head is 0.5.
Yes.
Right?
Yes, ma'am.
And when were we rejecting H naught? We were rejecting H naught when T is greater than
Not
C.
equal to fine.
When T is
Greater than
greater than C. So T is greater than C. So now you know, like this is this T is basically a binomial distribution.
Yes, ma'am. Can't it be converted into a normal distribution?
That can also be done. But this is a
Because
very
we
basic
have 100
example here.
tosses, so it's possible, right?
Yeah, it is possible.
Yes.
So what we are doing, we have to find the probability that we are rejecting H naught, and we are rejecting H naught when T is greater than C, right? So you have to do the summation like n choose k p to the power k and 1 minus p to the power n minus k, and your k should vary from C plus 1 till 100, right? That is what has been done here.
One thing you have not explained till now is what is this acceptance set? Because
acceptance set,
suppose
okay.
In first line we are saying alpha is probability to reject H naught when H naught is true. Then probability of A complement. This A complement comes from acceptance set only, na?
Yes. So acceptance set is for all those tests for which you are accepting your H naught. Like you accept the null hypothesis, all such tests are going to come in A. So here, like the test is reject H naught if T is greater than C. Okay, for some constant.
Let us take there are 100 tosses. Let us take the suppose when the heads are greater than 30, we reject it.
Heads are greater than 30, we reject the null hypothesis.
Yeah.
Okay.
So means when we conduct a test, so we started a test. We started a test. Toss 1, toss 2, toss 3, so on.
So
we get 29
you are
heads.
saying T is greater than 30. If T is greater than 30, we are going to reject the null.
Yeah. Suppose we get 29 heads in 100 tosses.
So what did we get in acceptance set?
That the number of tosses in a particular test should be 29 or less.
29 or less, right? So it
30 or less, actually it was greater than 30. Na?
Okay, greater than 30, yeah. So less than equal to 30. That will come into your acceptance set.
Okay.
So all those outcomes for which your T is coming to be less than equal to 30, that will come in your acceptance set. And apart from that, if you take the complement, for that you are rejecting your null hypothesis.
In this, we are taking only one sample of 100 tosses.
We are taking only one sample of 100 tosses, yes.
Okay.
So this is how we had found this significance level. And now we have to find the power. So what is power? Power is 1 minus beta.
Excuse me.
And yes.
If someone told that if we take the outcome is 30, greater than 30 means we need to take that is HA.
Okay, the question was there, like we take, let's say my test says reject H naught if number of heads is greater than 30. So if your number of heads are coming to be greater than 30, then we are rejecting H naught, right? So when are we going to accept H naught? when
Yes,
number
ma'am.
of heads is less than equal to 30.
Ma'am, but we are taking H naught as equal to 0.5, right?
In this case, that is the
We are
In
that
this
is the
taking H
case,
now.
naught as
If
yeah.
it is
50, yes.
50 means that belongs to that condition now. So
So
that's
here we don't know what this says. Like we have just said it's some critical. I mean, so for some constancy. I mean, if your number of heads comes out to be greater than this C, we are going to reject H naught. That is all we are saying. We have not given any number.
Okay. Ideally, this C should be greater than 0.5, right? Greater than
No, not 0.5.
greater
I
than
mean,
50. Greater than 50.
ideally, yeah, you would believe this.
C should
Like,
be
yeah,
greater than 50
we would expect this to be greater than or maybe
because our
60.
HA is point.
I mean, we can also say 60. 60 even seems reasonable.
Yes, yes. So this C we can change according to the significance level we want. But it should be
Yes,
greater.
according to the significance level you want, we can keep changing this.
But it should be greater than 50 and
Hmm.
it should be greater, not less than 50.
Hmm.
Ma'am, is
Yeah.
it so? It can never be, it can never be less than 50.
If it
50
is
heads.
less than
Even
50, then
yeah, even that we cannot say. I mean, I would say 40 to 60 would seems reasonable.
Okay, you have taken a range that if the probability of heads lie between this, I
Like
can
I
say
would
that.
say I can accept the null when it comes out to be in between 40 to 60. Like this is my choice. I mean, somebody can say something else. Yeah.
Okay, you mean to say that ideally it should be around this 50% of the heads, right?
Hmm.
Our coin will become counterfeit.
Counterfeit, yeah. Like I'm saying I'm taking my this T to be my acceptance should set so should be this T is lying between 40 to 60 or let's
Okay,
say
ma'am.
35 to 65.
Can I give another example related to this only? Suppose the
Okay.
suppose the coin is, we consider the coin to be counterfeit, right? It has
These
heads on both of its sides. It would always give head.
It will always give head, yeah.
So 100 tosses means 100 heads.
100
So that
tosses
means the
means 100 heads.
right? That means the coin is counterfeit clearly because
Yes.
heads are greater than the range. If the heads are even less than range, suppose I was talking about that heads are say we are going to reject when the heads are greater than 30, right?
Yeah.
Then also it makes it counterfeit.
Then also it makes it counterfeit. But yeah, so there this alpha comes, right? You would also want the significance level to be low. Like you'll have to balance between this C and this alpha. Like you'll have to.
Yes, ma'am. Sir was also explaining that we have to balance, but why we have to balance? Could you explain just this
Because
concept a little bit?
we want to reduce this error, right? I mean, you want to, you know that you since alpha is this probability of making this type 1 error, you want to reduce this error. You don't want this to go so high.
We want to reduce this error to maximize the accuracy of the experiment.
Yes, to maximize the accuracy of the experiment. And what does power does is power I mean, power, the more the power you have, the more strong you will have the belief that you are right. Right? And what does the power says? Power says, even though the alternative is true, we are rejecting H naught. It means we are accepting H naught. I mean, H is true and we are accepting it. So that also you want to be as high as possible. So
Okay,
you want to balance between this alpha and this power, basically. You want your alpha to be low and you want your power to be high. So
excuse me, as
yes.
of now, just for given problem, we can find out what is the alpha value and what is the beta value.
Yeah. So yeah, these are the things that you should be able to do from week 11 onwards. So first thing is identifying your null and alternative hypothesis. This is one thing. Then you should know how to find the alpha probability of making type 1 error. You should be able to find your power that is probability of making that is 1 minus beta, and you should also be able to find this power, that is probability of making type 2 error. So these three things you should be able to do it. I mean, because only once you know how to compute these things, on that basis you can come to a conclusion whether you're going to accept or whether you're going to reject.
So for given problem, we find out these things and test these things and test the given problem using this metric and finally give conclusion regarding those things.
Yes.
Okay,
So
we
significance
want
level, significance level, we generally keep it from our side. Like we want the significance level to be like, let's say 0.01 or 0.05. We fix it and then try to find such critical value.
What is the actual meaning of this significance level practically? What we want to what we want to represent with this significance level?
Yeah, so significance level is the same as like you don't want to make the error more than that. I mean,
Tolerance
you
limit.
can have
like
Yeah,
threshold.
ma'am,
you
that
can
is
manage to keep this error, but not more than that. Basically, you're saying.
okay. Suppose we say we are calculating some tolerance of something, right? We just said that is plus minus 5%.
So So we want the tolerance limit to be just 5%.
Oh, that means that is the meaning of significance, right?
Yes.
Okay.
Ma'am, actually, we are not able to correlate everything, ma'am. Can you please take one real-time example, and if you relate with each
I'll take
steps,
one example from here.
like which is
First,
acceptance test and power, size.
before going to the real life example, just go with the basic example first, okay?
Okay.
Yeah, we'll do one problem here. Let's take, yeah, this looks better. I will.
Ma'am, actually significance
solve it.
with significance level, what we want to say that although I would have performed a large experiment, right? But the probability of my error in this experiment is say 2%.
Okay.
That is what we want to tell others, na? Ki I have performed this experiment with so much accuracy.
No, I mean, but how do you find this critical value then? I mean, you want like for what critical value you had this accuracy?
Yeah, that I would define na, that suppose in this example only we are taking heads to be, if the heads are greater than say 50, we are going to claim that the coin is counterfeit.
Okay.
Then the significance level would tell that my error in all these 100 tosses, I performed say some error. I would have manually or in my program there is some error, and I want to tell others that the level of this error is so much.
Okay.
This is what significant level represents.
Yes, like you have already decided on your critical value. Like you're saying you will reject if the T's comes out to be greater than 50.
Yeah.
And from there, you are finding if this is the situation, then how much error you are getting, how much significance level you are getting.
Yes, ma'am.
Yeah. So, yeah, what was the question? Yeah.
Yeah, that suppose you give me a coin, I toss it 100 times. I say to you, this coin is counterfeit. You would ask me, how can you say that? So I would say that because I am getting more than 50 heads or at my part, I wouldn't declare. But I would tell you that my level of accuracy was what we calculate as significant level. So that is only how I am going to claim. Na? If my significant level is more than 30%, you would say that your experiment is wrong. You are making 30% more than 30% error.
Yes.
Your experiment is not accurate.
Yes. I mean, if you're making a lot of error, so the result that you have gotten is, I mean, one would
It's
believe
not up
that
to the
it's
mark.
not, yeah, it's not
You
up to the
cannot,
mark.
yeah.
Yeah.
Others would not believe. Na?
Yeah.
The prediction would be wrong.
Correct.
The significance level will depend on the problem which we have, right? So in certain conditions, we want a very low significance level. In certain conditions, slightly higher significance level is acceptable. That's what I understood. Is it right?
Slightly higher, it should not be too much.
Yes, yes. Normally 0.05 or 0.01 is.
And yeah, generally till I say 10%. Mostly we take it to 1% or 5%. Like if you see a lot of problems, like you will see that it is 5% or 1%. Okay, so you have one
So it
question
will
here.
depend on tolerance limit, like how much you can tolerate.
How much you can tolerate? Huh?
Yeah, it will depend on that, depending on the situation.
So the question here is, you have 100 samples. You have 100 samples, and the samples are x1, x2 up to x100, and they all are coming from a normal distribution with mean mu and variance 1. The null and alternative hypothesis, the first thing is we write what is null and alternative. So null hypothesis, we are writing this is mu equal -1. This is already given to us. And alternative hypothesis, we are writing that mu equal 1. Now, the second thing is we decide what is my test statistic. So here we already have the test statistic given to us. So the test statistic which we denote as T, and this is given as the sample mean. So sample mean will be x1 plus up to x100 divided by 100. Now the third thing is how are you defining your test? So here I am defining my test as I will reject H0 if this T comes out to be greater than C, where C is a constant. So the question is, what is alpha and what is power? Okay. So to find the alpha, so we'll write the definition. What is alpha? Alpha is probability of making type 1 error. Okay. And this is probability that we reject H0 or given H0 is true. So when are we rejecting H0? We are rejecting H0 if T is greater than C. Okay. So we are rejecting H0 if T is greater than C, given H0 is true. And what is H0? H0 is mu equal -1. So we'll write when mu equal -1. And what is this T here? T here is x bar. So x bar greater than C when mu is equal to -1. Now you see that you have a big enough sample size. You have a sample size of 100. So you can using CLT you can convert this to Z form, right? You can convert this to Z, and what will Z become? It will be x bar minus
N mu.
Not n mu, x bar minus mu, right?
Mu by
Okay,
sigma.
okay. This is one sample, right?
X bar minus mu upon sigma upon root n. So sigma was 1.
Yeah.
Root n was okay. Let's write root n. So basically, it will be x bar minus mu. And what is mu? Mu given to be -1. So this is x bar plus 1 divided by 1 upon under root 100. So 1 by 10. Okay. So we'll convert this to the normal form. So you will get this x bar minus, so plus 1 divided by 1 by 10. This is greater than C plus 1, right? 1 by 10. This is what you got. And this is your Z. So probability that Z is greater than C plus 1 10 times. Okay. And what can you write this as? You can write this as to be 1 minus FC of 10 C plus 1. Right? This you got to be your alpha. Are the steps clear?
Yes, ma'am. Ma'am, can you please move to page number 1, ma'am, for a minute?
Okay.
1 second, ma'am.
I'll go to the next page.
1 second, ma'am. Last line. Sorry.
Okay.
Ma'am, in 3 tests, reject HO if T is greater than C. And what you have written, ma'am, after that?
C is a constant.
Okay.
This problem is already there in the lecture, so you don't have to
Okay,
write.
okay, ma'am. Then it's okay, ma'am.
Yeah.
Ma'am,
So
could you explain when we normalize this standardize this normal distribution?
I
We
mean,
use
whenever you have a big enough sample size, it's good to normalize. I mean,
yeah, it's a
when
normal.
saying a big enough sample size, I mean at least 30. Right?
Yeah.
So it doesn't matter what distribution your samples are coming from, you can always normalize it.
Yes, ma'am. Then standardizing, actually you're converting here to normal 0 1. Na?
Normal 0 1, yes.
In CLT we used to do that x bar minus n mu by root n into sigma.
Not x bar. It was not x bar. It was s minus n mu upon, or y minus n mu upon sigma under root n.
Yeah, ma'am. This one.
This was it. But it's the same thing, no? I mean, you are writing. Okay, you are saying x1, x2 up to xn. These samples are, let's say, coming from x. Okay, and a first form I've written this x bar minus n. So x bar minus mu upon sigma upon root n. This is z, and here mu is expected value of x, and sigma is standard deviation of x. Okay. Now the second form we say is also y minus n mu upon sigma under root n to be z.
Yes, ma'am.
Where y is this x1 plus x2 plus up to xn. All right. You can always convert these. I mean, you can write, see, this is x1 plus x2 plus xn, right? Minus n mu divided by sigma under root n. Okay. Now you divide numerator and denominator by n. What will you get? You will get x bar minus mu upon sigma upon root n, right? It's the same thing. Look over here. Same thing.
Yes, ma'am.
So basically, how you can remember is, see, this x bar minus mu, and what is mu? Mu is expected value of x bar, and what is in the denominator? This is
standard deviation.
Standard deviation of x bar. Okay.
Yeah,
now
here we are working with a sample mean, na?
Now you look at this. So this is what? This is y minus expected value of y divided by standard deviation of y. Right?
Yes, ma'am. Got it.
This is how you can work.
Yeah, this is equivalent to standardizing the variable, random variable.
Yes. So this is how we got R alpha. Now, if we have to find the power, okay? So power is 1 minus beta. And this is what? This is probability that like given HA is true, you reject H0. Okay, so we were rejecting H0 when T is greater than C. So T was X bar, right? This X bar was greater than C given HA is true. So what was HA? HA is mu equal 1. Okay. So again, we'll do the same thing. So in this case, how will you convert this to Z? How will you convert this to Z? This X bar?
X bar minus mu by sigma by
What
root
is
1.
mu? What is mu?
1.
Here
1. So X bar minus 1 upon 1
1.
upon 10 greater than C minus 1 upon 1 by 10. And this becomes 1 minus FC of 10 times C minus 1. So this is your power. So now you can just substitute different values for this C and get your alpha and power.
Ma'am, can you show this mu and C in the graph of this normal distribution? Where
Graph
we
of this normal distribution.
like which part we are rejecting and which part we are accepting?
Okay, so basically, okay, this is a normal distribution. This is a normal distribution 0 1. So mean is 0, and this is your alpha. These combined will be your alpha. Okay. So this alpha is the significance level. Now we have okay. We'll look at 3 tests here. So let's talk about only test for mean. We are in week 11. We are going to look at only for test for mean. Okay. So we will have 3 cases. The first kind can be when your H0 is mu equal mu naught and HA is mu greater than mu naught. Okay. In that case, let's say my test statistic T, or let's say just the test statistic is T, that is enough. And the test is that we reject H0. So when will you reject H0? When T comes out to be greater than some critical value. And how did we come to this? By looking at the alternative hypothesis. Okay. So alternative hypothesis was like you are rejecting H0 when the test statistic comes out to be greater than this critical value. Now you will have when you solve for this alpha, you will have this graph, and this graph is for basically this T. Okay. So what is the test? Test is reject H0 if T is greater than C. When T is greater than C. So let's say this is your C. So T is greater than C, it means this area. Correct? Oh, this is your alpha. But if I say that
ma'am, where is that mu naught here in this graph?
This is your mu naught.
Okay, mu naught is the distribution is just revolving around this mu naught, and we are rejecting the test if it is greater than C.
Greater than C, yes. If my test comes out to be greater than C, this test statistic value, you will reject H naught. And this is your alpha. Just give me a minute. Wait. I have already something prepared. Okay. Okay, so can you see this?
Yes, ma'am. Yes, ma'am. It's visible.
Okay. So the first, you have three tests for mean. I mean, you in this lecture, not in this lecture, in this week, we have seen just the Z test. Okay. So in Z test, we are testing for mean, only for mean. And it is, you have three different variations. One is called the right tail test, other is called the left tail test, and the next is called two tail test. So in left tail test, you have the H naught to be mu equal mu naught always, and HA, you say your mu is greater than mu naught. So like the figure, as you can see here, you have this normal curve, and which is centered around mu naught, and this critical value, at this critical value, after this, if your test statistic, test T, if it comes out to be greater than C, we are going to reject our H naught. So that is our rejection reason here, this part. And this is called alpha. So anything to the left of this is called the acceptance reason. Okay. How do we find the type 1 error, type 2 error? That we had already seen. And now if we go to the left tail test, how it will be is like your null will be h naught mu equal mu naught, it will be same, and HA will be your mu is less than mu naught. Okay, so mu is less than, instead of mu greater than mu naught, you have mu less than mu naught. And the test will be that we reject H naught if T is less than C. Okay, so since the alternative is mu less than mu naught, I'm giving my test as that reject H naught if my test statistic comes out to be less than this critical value. So if you look at this figure again, you have so this graph is for your T, and it follows this normal distribution with mean mu, variance sigma square by n. Okay, and this is centered around this mu naught. And my test is that we reject H naught if mu is less than, this T is less than C. So our C will be somewhere here. So T is less than C means this part. Okay, so that is our alpha, and anything to the right of this line is the acceptance reason.
Okay, ma'am. Now got it.
Got it. Now
Yeah.
there is something called two-tail test, right? So in two-tail test, we say my the alternative is HA is mu
Greater
not
than
equal
some
to,
critical value and
yes. So it will be like both sided.
it can be like this, ma'am. Like we
So
can say that
combining
mu
both.
is greater than C1 and mu is less than C2.
Mu is less than C1. Yeah, you can say that. But since it is a normal distribution, you know this C, and it will be just C and minus C. Right?
Ma'am, one doubt here.
Hmm?
In this case, mu naught is just one single value.
Yeah, it is a one single value. It is a constant, right? Mu naught is a constant.
But mu, I have understood that mu is greater than some C1 and mu is less than some C1. These two cases I have got it. But mu is not equal to mu naught. Should it not be all the area except the mu naught?
Okay. No. It is not like that. So, yeah. When you have a two-tail test, okay, H naught is mu greater than mu equal mu naught, and HA is mu naught equal to mu naught. And we are taking the test statistic to be same as sample mean, let's say. And we are saying reject H naught if this x bar minus mu comes out to be greater than C. So this x bar minus mu, side it here. So reject H naught if mod of x bar minus mu is greater than C. So this is, we are saying this reason inside is the acceptance reason.
Okay, ma'am, now got it. Now got it.
You got it?
We are just talking about mu, and this mu is some, we have to take that, compare it with some critical value.
Yes. Huh.
Okay.
Ma'am, for the two-tail test, can we understand it like whenever an alternate hypothesis is not equal to, then it is two-tail test?
Yes. It's exactly the same.
Okay.
So these three tests, three different variations for the Z test you're going to see. So Z test is nothing but testing for the mean. Whenever you have a situation, you have a problem, and in the problem you are testing for the mean. We call it the Z test. So you will also look at, there one more test you will see in week 12. So I will not go to that. So that is called T test. So that is also test for mean, but different variations. different situations. Okay. Then next we have simple hypothesis. Yeah, all those one sample test is there. So right-tailed, left-tailed, two-tailed. So this is we are going to see later. Like here also you can see you have the figure for this when are you rejecting this area, like which is your acceptance reason and which is your rejection reason. Okay, let's look at one problem here from Z-test. It says, suppose an app is desired to make an accurate identification of faces in photographs more than 90% of the time in the long run. For a random sample of 500 such photos, the apps makes the correct identification 462 times. What does a Z-test say about the null hypothesis that the app is only 90% accurate compared to the alternative that the app is more than 90% accurate? So again, the null and the alternative is properly defined here. We have what is the null hypothesis here? What is the null hypothesis here?
The probability of it is the success rate. It is 90% accurate.
90%, yeah.
Probability is
So P,
0.9.
yeah, probability is 0.9. And what is the alternative hypothesis?
Alternative
It's
is
not
that
equal to 0.
No, it's all explicitly mentioned here. Compared to an alternative hypothesis that the app is more than
More is
90%.
okay. Yeah,
So
got
P
it.
should be greater than 0.9.
Yeah.
Okay. Now we have to design the test. So this is what test? Right tail test or left tail test? This is a right tail test, right?
Since it is greater than, right? No?
Because we are rejecting H naught if P is greater than 0.9.
Okay.
So the test will be so okay. Here you have like it has been solved using P. So are you aware of how to convert this proportion thing to the normal distribution? I mean, it's the same thing, but do you know how to convert it? Like when we were dealing with mu, it was this x bar minus mu upon sigma upon root n. What about the p? How, like what will be the set like normal 0 1 form? Anyone? Hmm. Anyone? Can you tell me?
Yes, ma'am. What's the question?
The
Ma'am,
question
is
was like if we had to test for the mean and we say the test statistic was when x bar, then in that case if this x bar minus mu upon sigma upon root n, we said it's normal 0 1. But here we have the proportion given. So what about in this case, like what is your normal? So how will you convert your test statistic to the normal 0 1 form?
ma'am, it is same like a normal of mean and variance, right, ma'am? So mean
Yeah,
is
so
p and
what
variance is p into 1 minus p.
variance is?
P into 1 minus p.
P into 1 minus p, yes. So what will be the form?
It's x bar minus p divided by p into 1 minus p because you have to subtract the mean and divide by the variance. Square
No,
root of p.
we divided by standard
Standard
deviation.
deviation, sorry, square root of p into 1
So
minus.
it will become this x bar minus p divided by under root of p in p times 1 minus p divided by 500 in this case.
Yes.
Can you find the alpha for this? I will not show the solution here. Can you find the alpha? Just first try it out, then I will explain.
अगर दे दो.
Just take some time and try to find alpha for this.
Alpha is already given, na ma'am, 0.05.
Oh, right. Alpha is given. Okay, find this is critical value in this
C,
case.
C, right?
Yeah,
Okay.
find C. Yeah.
Yes, ma'am, it's F inverse of 0.95 into 0.3 by 10 root 5 plus 0.9.
What answer did you get for C?
C is equal to
Okay.
F inverse of
Okay.
0.95
Okay.
into 0.3
Okay.
by 10 by root 5
Okay.
plus 0.9.
Plus 0.9. All right. Anybody else?
This is assuming alpha significance as
0.05.
Yes.
Anybody else who has solved? Okay, just wait for 2-3 more minutes.
Ma'am, I have a question regarding the quiz 2.
Okay.
In one of the questions,
Okay.
it was not mentioned to what till what number we have to mark the answer, to 2 decimal places or 3 or 4. That was not.
What question was that? Do you remember the question? Hello? Do you remember the question? You're there? Okay, anybody else who has solved this? Any answers? No one?
Which answer you are talking about, ma'am?
Oh no, you were saying something about quiz 2, right?
Yes, ma'am. The answer is 1 by e to the power minus 1.
Okay.
And it is going to come in decimal only, but it was not given whether we have to give up to what decimal, 1 or 2 or till what decimal.
Oh, okay.
Generally,
If
it
it
is
was
given up
not,
to 3 decimal.
yeah, okay. If that was the case, and if the answer was 1 by e, and it was not
1 by
given,
e.
then it will get managed. We'll do it.
Okay.
Yeah.
Because in the answer also it is given as 1 by e only, the answer key also.
Okay.
So I marked it up to 3 or 4 decimals. I don't know. I don't
Okay,
remember.
okay. Yeah. If it is
So
not given, then yeah, it will get managed. Yeah.
Okay.
All right. Anybody else done this problem? No? Okay, let's see then. Let's see if the answer is right. So C is 0.9 plus, okay. This is not the answer you got, right?
Yes, it's 0.9 plus S. It's right, ma'am. It's 0.9 plus square root of 0.09 is 0.3.
Okay,
0.3 by 10
0.3
root 5.
by 10 root
10
5.
root 5.
Okay, right.
F inverse of 0.95.
Yes. Okay, anybody else who wants to know the solution? Are you guys solving?
Yes, ma'am, just explain the problem, how to approach it. Don't do the solution, just explain
Yeah.
to approach this.
All right. So H naught was P equal 0.9. HA was given to be P greater than 0.9. And according to that, our test is reject H naught if X bar is greater than C. Okay. Now, if the test is reject H naught if X bar is greater than C, and you already know the significance level, so you will have to find this critical value. Now, how do you find the critical value? This is using your significance level alpha. So alpha is probability of rejecting H naught if given that H naught is true. So we are rejecting H naught if X bar is greater than C. So X bar is greater than C given H naught is true. It means given P equal 0.9. Now we'll convert this to the standard normal form, this X bar, and we got this to be C minus 0.9 divided by under root of 0.09 divided by 500. Okay. And once you solve it, once you do all the calculation, you got C to be this particular expression, that is 0.9 plus under root of 0.09 by 500 FC inverse of 0.95. This is what you got. Now FC inverse 0.95 value we know. Okay, we already know the value, so from there you will get some C. So once you substitute that value, we got C to be 0.922. Now this is only till how do you find the critical value, but this was the problem.
FZ inverse has been calculated from the table, or where is it given?
It is from the table, or
okay,
I think in the lecture so it is done using the Python, the Colab notebook, but this can be done using the table. So FC inverse of 0.95, this comes from 1.64 value if you take. So if you put this as 1.64, you'll get C to be 0.922. Now we had to check, the question was, what does a z-test say about a null hypothesis that the app is only 90% accurate? So we have to check whether, using the z-test, what using the z-test, what can we say about this null hypothesis? So saying, what do you mean by what can we say about the null hypothesis? It means, are we going to accept the null hypothesis or are we going to reject the null hypothesis? And how are we going to do it? From our test, what the test we have defined. So the test we had defined was reject H naught if X bar was greater than C. C we already found, but how do you find this X bar? So this X bar, you see the second sentence in the question. It says, for a random sample of 500 such photos, the app makes the correct identification 462 times. So out of 500 times, 462 times, it makes a correct identification. So your X bar is 462 divided by 500, right? So how much is 462 divided by 500? It is 92.4. Okay. And this 92.4 is basically, this 92.4, this X bar comes out to be greater than C. So when X bar comes out to be greater than C, it means we are going to reject H naught. So the conclusion is we are going to reject H naught. It means if we are rejecting H naught, it means we are saying the space greater than 0.9. Okay. So many a times what happens is like what we have seen previously, that how to reach the conclusion is the where students find it more difficult. So just to go to till the conclusion, just check what your test is, and according to that, you decide whether you are going to accept or whether you are going to reject. Is it okay?
Yes, ma'am.
Okay. Shall we? Any doubt till so far, like whatever we have done?
Ma'am, let me know if my understanding is correct on
Okay.
solving the
Yeah.
problem.
Hmm.
So first step will be formulate the null and the alternate hypothesis from the given problem,
Yes.
and then identify the level of significance like alpha.
Okay.
And then we have to understand we have to come up with the acceptance and the rejection region, then find the test statistic, and then based on the test statistic value and the acceptance or the rejection region we have decided, we will whether accept or reject the hypothesis.
Yes. Yeah.
Okay, ma'am. Thank you.
Anything else? So there is one more topic left, that is p-value. We can do it next time, or you can also look at the recorded session that we're going to provide. So you can access it from tomorrow. So do you have any doubt so far, whatever we have done?
What can we access tomorrow, ma'am? We were just
Access tomorrow, like the recorded videos or the live session are not available currently. So by tomorrow morning, it should get updated, and you can also look at, so there are some 4-5 live sessions recorded from the previous term. You can, and they are annotated. So whatever topics you have doubt in, you can just go there and look at that part. So that will be helpful for you.
Ma'am, it's not specific to week 11, right? You're talking in general, the live session.
Yeah, in general, it is like that, but week 11 has not been updated yet. Saying.
Okay.
So it should get updated by tomorrow in your portal. Have we close the session for today?
Yeah, yes, ma'am.
Okay.
Thank you, ma'am. Good night.
Yeah. Thank you all. So just check on the portal tomorrow. From tomorrow, it will be available, and just look at the point where you have doubt, and you can watch those part. It will be clear for you. Like week 11, you already have a lot of videos available, and try to solve some problems too, because that will help you in understanding more.
Yeah, okay. Thank you, ma'am.
Yeah, thank you all. Thanks for joining. Good night.